Discovery of subatomic particles. So in this video, we are going to be talking specifically about the discovery of the negative subatomic particles, that is the electron. So first, before we start to study about who discovered and what and all happened, there was one person called William Crook, who is very important, or who gave us the basic idea of certain tubes called as Crooks tubes. And these tubes are actually, we'll be talking about it more in the next slide, but basically gases are bad conductors of electricity. So they only conduct electricity at extremely low pressures, and William Crook studied the conduction of gases at low pressures, and this for which he used a discharge tube. So there are various types of discharge tubes which exist. So the one which he used and invented basically is called the Crookes tube. So in this Crookes tube, you have a glass tube which is almost 60 centimeters long. It is sealed on both ends. If you see, it's sealed. It has metal electrodes, whereas the cathode and the anode are made of metals, and there is a vacuum pump which is connected to maintain the pressure. You have an extremely high DC voltage. So the reason we have such a high DC voltage is to ensure that the amount of electricity that gets supplied is very high, and you also an extremely low pressure is being maintained. So what happened was, when a high voltage was applied, it was noticed that there is a green color fluorescence that appeared behind the anode, for which they used a perforated anode. A perforated anode basically basically can let radiation pass through. And so he noticed that there are something called as cathode. I'm sorry, it's supposed to be invisible. So he noticed that when a high voltage is applied, there are radiations which are emitted from the cathode, and these are called as cathode rays. And the glass here, this area, became fluorescent color, and because it's coated with zinc sulfide. So actually, I think the first time this happened was out of an accident, and they noticed the fluorescence, and that's when they realized that there are something called as cathode rays which are forming at the cathode, which are moving towards here and leading to this fluorescent greenish color. So electron was first discovered by J.J. Thomson using these discharge tube experiments. So the various experiments were carried out by him and various other scientists. And this is how we got to know about the properties of the cathode rays. So first one is cathode rays travel in a straight line. So here, if you can see, there is an object placed, and only because it's traveling, the rays are traveling in a straight line, is a shadow for me. If there was no, I mean, if didn't have traveled at a straight line, this shadow wouldn't have formed. So this means that cathode rays travel in a straight line. Next, they're made up of solid particles. The reason we say this, because when they placed a solid object like this paddle in between, it started to move. So this meant that these cathode rays are made up of some particles, which is ensuring that this paddle is getting pushed, and it gets, I mean, basically it's moving. Cathode rays carry a negative charge. So as you can see over here, here you have a high DC voltage, as we know, because the gas has to conduct electricity. Here, the cathode rays is being exposed to an other voltage which is quite low. It's almost 10 volts only. But when it was exposed to such a voltage, the cathode rays acted like something which is negatively charged. So a negatively charged particle will get attracted towards the positive side, and so it started moving, it deflected upwards. This meant that cathode rays consisted of a negative charge. As you can see over here, a magnet is being used, and the cathode rays are getting deflected. And this also shows that, and this shows the property similar to what is expected for when cathode ray is supposed to be negatively charged. So this is why they considered, or rather they deduced, that cathode rays have a negative charge. The fourth is it produces a heating effect. So when the cathode rays hit a metal foil, they led to heating of that particular foil, and this meant that cathode rays produce a heating effect, and they do not depend upon the nature of the electrodes or the gas in the cathode ray tube. So this is one very important thing, because this forms a very important difference between the cathode rays and the anode rays, which we will be studying about when we study about discovery of proton. But cathode rays, they do not depend upon the nature of the electrodes or the nature of the gas. So they're independent of the characteristics of the objects that is being used in the cathode ray tube. So in this video, we had studied about the fact that electron was discovered by J.J. Thomson. One important thing, William Crookes was the person who gave us the Crookes discharge tube, and that in turn gave us basically helped in discovery of the electron. There are five important properties of the cathode rays. They travel in straight line. They're made up of solid particles. They carry a negative charge, and they produce a heating effect. And the nature does not depend upon the nature of the electrode or the nature of the gas in the cathode ray tube. In the next video, we will be studying about charge to mass ratio, as well as the charge. How was it determined of the electron? So do check it out.